Good day, everyone. You were assigned to solve for a problem about the applications of complex numbers. So for a given, we have total voltage is equal to 220 CJS, 180 degrees volts. For our resistance, we have 100 CJS, 16.16 degrees ohms. For the XL, we have the inductive reactance, which is 80 plus J60 ohms, and XC, which stands for inductive capacitance, which is equal to 100 CJS, 73.74 degrees ohms. Next, we have the diagram, which is shown in figure 1. Now, in order to start solving, we must convert the values, which are in rectangular, to polar, and vice versa. In this slide, we can see the conversion of the given values. First, when converting the resistance and capacitance to the rectangular form, we will get the resistance, which is the 96 plus J28 ohms, and the capacitance will now be 28 plus J96 ohms. For the reactance, we can get the value of the modulus by using the formula of square root of a squared plus b squared, which will give us the modulus of 100. And for the argument, we will use the formula of theta is equal to arctan b over a, which will now give us a value of 36.87 degrees. And now combining these values, we will get the new reactance or the polar form of the reactance, which is 100 CGS, 36.87 degrees ohms. Now, here we can now see the updated diagram, which contains the polar and rectangular forms of the given values.
Now, the formulas we're going to use are I is equals ET over Z for current, where it is the total voltage and Z is the impedance, and Z equals to square root of R squared plus quantity of X sub O minus X sub C squared for impedance. So now, before we can solve the current, we need first to solve for the impedance. To solve for the impedance, we will use the formula of Z equals square root of R squared plus quantity of X sub O minus X sub C squared. So substituting the values, we'll get Z equals to square root of 100 CGS 16.26 degree squared plus quantity of 80 plus G60 minus quantity of 28 plus G96 squared. So we need first to distribute the exponent for 100 CGS 16.26 degree. We'll get 100 squared CGS 2 times 16.26 degrees. Will give us the answer of 10,000 CGS 32.52 degrees. 52 degrees. With that, we will get Z equals to square root of 10,000 CGS 32.52 degrees. We also have to consider the rule of adding complex numbers, wherein we simply add real parts and adding the imaginary parts separately. We get 52 minus 336. With that, we'll get Z equals to square root of 10,000 CGS 32.52 degree plus 52 minus 336 squared. Next, continuing. Before we continue, we need first to convert 52 minus G36 to polar form. So to convert that, we need to use the formula of we need to use the Pythagorean theorem, which is R equals to square root of A squared plus B squared. So substituting the values will give us the answer of 63.25 as our modulus. So to get the argument or the angle, we'll use the theta equals to arctan B over A. So substituting the values will give us negative 34.70 degrees. We also have to distribute the exponent for 63.25 CGS negative 34.70 degrees will give us the answer of 4,000.56 CGS negative 69.4 degrees. With that, we'll get the answer of Z equals to 10,000 CGS 32.52 degree plus 4,000.56 CGS negative 69.4 degrees. So to proceed, we need first to convert 10,000 CGS 32.52 degree ohms to rectangular form. So to convert that, we'll input in our calculator 10,000 cosine 32.52 degrees plus G 10,000 sine 32.52 degrees will give us the answer of 8,432.04 plus J 5,375.94. We also need to convert 4,000.56 CGS negative 69.4 to rectangular form. So we'll give us the answer of 1,407.56 minus G 3,744.76. So we'll get Z is equals to square root of 8,432.04 plus G 5,375.94 plus quantity of 1,407.56 minus G 3,744.76.
So next, we need to convert our answers to polar form by first is to separate the real numbers from the imaginary numbers. So once that we have separated our the real numbers and the imaginary numbers, we need to add them separately. So once we already add them separately, we now have our answer of 9,839.6 and 1,631.18. So we just need to combine them to produce an answer of 9,839.6 plus J 1,631.18. So next, now we need to convert them to polar form. So to convert rectangular to polar form, we need to use our Pythagorean theorem for the modulus, and for the argument, we can just use theta equals arctan b over a. So first, to solve for the modulus, just use r is equals to square root of a squared plus b squared. So using this formula, we now have the answer of 9,973.89. And for the argument, we can just use theta equals arctan b over a to have the answer of 9.41 degrees. So once that we have the answers for modulus and argument, we just need to combine them together to produce the answer of 9,973.89 CJS 9.41 degrees. Okay. So next, now that we have our answer, we need to remove the square root from the equation. So to remove the square root from the equation, we need to square the modulus and multiply the argument to 1/2. Okay, so in doing this, we have 99.87 for the modulus and 4.71 degrees for the argument. Okay, so our impedance is 99.87 CGS 4.71 degrees ohms. So now that we have our impedance, we can now solve for the current. So to solve the current, we can just use the formula of current is equals to total voltage over impedance. Okay, so uh, now that we have both of the values, we can now use the formula. To solve for the current, just input the values. So current is equals to 220 CJS, 180 degrees volts, over 99.87 CJS, 4.71 degrees ohms. So the answer to this is current is equals to 2.20 CJS, 175.29 amperes. Now that we have the answer for the polar form, we can convert it to rectangular form. So to convert the answer to rectangular form, just use the formula of modulus cosine argument plus j modulus sine argument. So using this formula, now we have the answer of negative 2.19 plus j 0.18 amperes. So our final answer for the current is equals to 2.20 CJS, 175.29 amperes, or negative 2.19 plus j 0.18 amperes. Okay, so thank you for listening to our video of how to solve complex numbers on this given problem. So I am Kurt Rizano together with Mr. Ko and Mr. Kagsawa. Thank you again for listening.